All right, Calculus, I have received some very good questions about the upcoming homework sets. That's good. We are nice and focused and ready to go. I will definitely be seeing you on Monday the 1st. Just got back from the surgeon and everything's going great. It's going as good as it can. So I will see you on Monday. In fact, I'm going to be popping in on Friday just to unload everything I have, get a lay of the land, as I will be in that sweet, sweet scooter for at least 6 more weeks. All right, so here we go. So after our emails and whatnot, and some good questions I received, homework set. It's not supposed to fall out. Homework set number 3 looks like this. So homework set number 3, you have all of this type of question. Find the equation of the line, which is tangent to the given curve at the given point. You have 12 of those. Now I want to show you exactly the type of work you need to show. Now I made a boo-boo. Forgot to have this on my scratch paper squared. That makes a big difference if you plug -1 in, right? Yes. Versus -5x versus -5x squared. Okay. So you are using the limits, the slope of the tangent line is equal to the limit as x approaches a of f of x minus f of a over x minus a. That's one of the 3 formulas you're going to have memorized. That's where you're using. Anytime you see slope of the tangent line, again, you have to use the limit definition this chapter. Guys, Googling things is fine, but you need to make sure that you Google limit definition of the equation of the tangent line. Limit definition. Limit definition of the derivative. Any other way to do the derivative, folks, we haven't learned that yet. I'm not going to give you any credit. All right, so some of you might have got, you could have gotten right answers, but you didn't show the correct work, so that's costly. All right, we can't show something that we're not on right now. All right, limit definition that even you can show your work in a different way on the final, but you're going to have a question that says using the limit definition of a derivative only. What's the derivative? All right, we'll talk about that on the next question. So this one is, here's the curve, here's the point. So what you need to show, notice I said, this is everything south of here you got to show. You have to say the slope is equal to the limit as x approaches -1. Write out the entire f of x minus f of a all over x minus a. Don't abbreviate, don't like take any shortcuts yet. Now you can simplify that. Again, I made a boo-boo. Now you simplify it, okay? So I have not plugged -1 in for x. So that limit as x approaches -1 has to be on every single step until you plug -1 in for x. This and this are 2 very different things. 2 very different things. You have to have the limit as x goes to -1. So you'd either show your work by factoring, or in this case, x to the 3rd power, use synthetic division. I highly encourage that you use synthetic division. Okay, some of us we're guessing on how it factors incorrectly, and that was a costly error. Again, this is 2x to the 3rd, -5x squared, -7x, and a 0. Some of us had errors with 0, whether we skipped x squared or x or the constant. Got to have a 0 there. Bring down the 2 because we're doing 2 divided by 1. Bring down the 2. Do the synthetic division. -1 times 2 is a -2. Add them up. -1 times -7, 7. Add them up. -1 times 0, 0. Add them up. 2x to the 3rd divided by x. This gives me 2x squared minus 7x. That's it. You have a -7 there, so make sure to bring that down. All right, some of us in the last one had like +7 here and wrote -7 or something. Okay? Now, again, you have to write the limit as x goes to -1. The slope is equal to the limit as x goes to -1. Now I can let x go to -1 because I'm not dividing by 0. I plug -1 in for x, -1 squared, and I get 9, and that's the slope, and here's my equation. Okay? Yes, you might think that that's a ton of work. Again, you got to get in the habit of being incredibly precise in every single step. Some of you guys are going to have some pretty demanding future jobs and maybe technical or whatnot. You got to be incredibly precise in each step and maybe do more than you think is necessary. All right, I'm glad the guy that just operated on my foot was incredibly precise in every step. So this is a good little training, okay? All right, and here we are getting adjusted here. This next one, this is on homework set number 4, numbers 1 through 5. Okay. Oh, I think they were. Never mind, Scott. Sorry. 1 through 5. So 1 through 5 is the limit definition of a derivative. Again, you have to show it this way. This is the limit definition of a derivative. If I ask for the limit definition of a derivative on your fall final, on your chapter 2 exam, obviously, this is what we're showing. You have to have this memorized, folks. So that is the difference quotient in letting h go to 0. All right? So I'm going to plug x plus h in for there and there. Now I'm going to subtract f of x. You're subtracting all of it, so be careful. So I just showed all of the algebra, squared it, multiplied everything by -3. I have not canceled anything yet. That might be a good idea. Let's wait till the very end to cancel. Again, what is continuing? Now, you can draw an arrow, f prime of x. You can draw an arrow down south. That's fine. But the limit as h goes to 0 has to be there every single step. If on your next, and some of you lost points, again, I told you, you have to have it there the entire time. If I tell you once, you got to follow those directions. It will be a costlier error if we don't have that on every single step in our next homework assignment. All right, please do not rush your homework. Start early. Again, we're thinking about next year. We're thinking about next year. How can we handle it then in the big leagues? All right, x, -x, -3x squared, 3x squared. There we go. Now I divide everything by x, but by h, but I have not let h be 0 yet. I divided everything by h. Great. Now I'm finally saying, hey, h, you're 0. And there's my answer. All right? Follow that, follow that, follow that. All right? It's pretty clear the work you need to show. Take your time. Now, homework set 4, I'll say like the first two, again, you've been given some really nice close examples. Go back to your notes. Always go back. Did Mr. Yak do something very, very similar? All right, always go back. Do the ones that you can, like right away. Try those. I would hope this is one. And then go back. Did Mr. Yak do something very similar? All right, answer that question is yes. Number 6 and 7 is like all of homework set number 3. Find the equation of the tangent line to the curve at a certain point. And 8's velocity. I've done at least 3 velocity. Again, this homework set is not due immediately when you get back. So I'll help you out, and you're going to have some quiz review questions where I talk about velocity. We still got a few more with velocity, but you can definitely do all of homework set 3 now. Now. You're watching this video on Wednesday, maybe Tuesday night. Do it all. Do it all. Try to have this done all the way by Thursday so you can review it on Friday. So you're ready to turn it like it's perfect and it's ready to go. And you'll be turning that one into me. You don't have to worry about submitting it to me via the interwebs. All right, this is Yak Math Videos. Signing out.